My name is Kenneth Koo. I'm the Group Chairman and CEO of the Tai Chong Cheang Group, better known as the TCC Group.
It's a shipping company. It's a shipping company. They have their own ships and they ship around the world. And they are based in Hong Kong. Is a family business.
I'm the third generation that has taken over the helm of the business. We basically own a fleet of vessels that transports raw materials such as coal, iron ore, grain commodities, crude oil, and its products.
The impact of the shipping industry on the economy is enormous.
Over 90% of consumer goods are shipped by ocean freight every year.
Shipping is the main mode of transport of goods around the world. It's the most cost-effective one. However, the type of fuel they're using, it's not as good as we have in our cars, for example. As a result, they produce a lot of pollutants, and those pollutants are very harmful for humans, plants, and the environment in general.
Of course, the one thing that no one is able to do anything about at this point in time are basically the CO2 emissions, the NOx emissions.
And the TIER-MDE program, sponsored by Kenneth Koo, is a program to address a major problem in pollution in the world, which is the shipping industry.
Mr. Koo has been a visionary, has realized this early, and he rocked the boat, just to use the marine-related term. And he realized this problem and he took action, started with us. He realized the merit of this technology and the capabilities we have at USC.
My son is a student here in USC and in the Viterbi School of Engineering. The reason why I decided to turn to USC was because I was engaged in a long and very insightful conversation with Dean Yanis Yortsos of the Viterbi School of Engineering. I started talking to him about the challenges we are facing.
Dean Yortsos had set up a meeting and introduced a number of research activities at USC to them. We were doing work on reducing emissions from engines by putting a plasma gadget in the tailpipe of an engine. We'd been doing work on that, and in doing that work we'd come up with some fundamentals that seemed worthy to try to use for other things. It's the creation of pulse generators that produce pulses that are very short but have very high peak power but low energy, to ignite and combust the fuels more efficiently in the combustion chamber of a huge marine diesel engine.
Dr. Gunnarsson is a world leader in nanosecond pulse power, which can be used to improve fuel efficiency. And Dr. Igafopoulos is a world leader in combustion science and research and really understands pollution and combustion efficiency.
My expertise is combustion, so I understand very well how fuel and oxygen come together and burn. When we apply the pulse power in an engine, the combustion becomes more efficient. That means less fuel will be used, and less fuel means less pollutants. Now, the pollutants that are formed even from this smaller amount of fuel can be also affected. We have shown in our laboratories that by discharging this energy in a combustion system reduces significantly the production of nitrogen oxides and particulates, for example, soot particles.
I think Viterbi has that extra edge because I haven't seen a school that is able to dovetail goals and objectives of the business world with goals and objectives, from academia. I haven't found an institution that can do it in such a good way, and especially speaking with Dean Yortsos, the way that he can so easily make that connection.
Clearly, energy is one of the most important issues facing not just our nation, but the entire world today. So I've always been excited to be working on energy-related projects, improving fuel efficiency, reducing emissions, and this is a technology that can fundamentally change the way we look at that, because we've been using the same type of ignition technology for the past 100 years. It hasn't changed. It's always been thermal-based. And now we're starting to get an understanding of this new technology, this new fundamental approach, transient plasma, that alters the combustion chemistry in a very major way.
The The fact that we're addressing a very difficult problem, marine diesels, is because of TCC.
We're very thankful to Mr. Kenneth Koo, who was a visionary and he saw this problem.
So my commitment is going to be that future generations of TCC's fleet of crude oil carriers and dry bulk commodity carriers will be powered, with this nanotechnology, this nanopulse technology. I think this is a groundbreaking collaboration that is really going to make the world sit up and take notice.
We do think this will play out in some way to reduce emissions and use fuels more efficiently.
And our partnership with TCC is a very important first step. We're looking also forward to future collaborations with the engine manufacturers, who at the end of the day have to implement this technology in their engines.
So I'm very excited that TCC and Kenneth Koo have taken such an interest and invested in this technology, because I really believe it's going to have an impact on our energy security in the future.